Hello, this is Peter from Edico Mondo, and a warm welcome to our STEAM project number 15 called The Beating Heart. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. In our previous lessons, we have programmed a single and a 4-digit 7-segment display. Today we have a look at the 8x8 or 64 LED display. The goal is to create the moving image of a beating heart. We will introduce to our class the creation of functions within the Arduino programming environment. Your students will learn about global and local variables. And last but not least, we will encourage teamwork in the classroom so that everyone is successful. Let us take a closer look at the 8x8 LED display. Sometimes it is also called a dot matrix display. With the 64 LEDs, we can create letters, numbers, smileys, and many other static or moving images. There are 16 pins coming out from the back of the display, 2 sets of 8 each. The display is controlled by switching on and off the rows and columns of the display. Each individual LED is at the crossing of a row and a column. Just like the 7-segment displays, you have versions with a common anode and a common cathode. With a common cathode, the columns are negative and the rows are positive. With a common cathode, you control an LED by switching the row high and the column low, creating a closed circuit. By doing this very fast, the principle of multiplexing, you create the impression of a letter, number, or image. Now we need to understand which pin is doing what. This is quite complex and isn't based on any apparent logic. Show this image to your class by copying it on the whiteboard or by making small reference cards. Now that we know the working of the display, let's distribute the components to our class. The microcontroller and the breadboard, the 8x8 matrix display, 8 resistors of 220 ohm, 16 jumper cables, and some preformed wires. As you can see on the Fritzing drawing, the final project is not that complex, and your class should be able to build this without too much help. In order to speed up the video, we will go over the different components step by step. The center of the project is the 8x8 digit display. The rows are connected via 220 ohm resistors to the digital pins 2 through 9. We do not recommend the use of the digital pins 0 and 1, as these are used by the Arduino itself to upload the sketch. You can see that these pins are labeled RX and TX, which is short for receiving and transmitting. We connect the column pins to the remaining digital pins and continue with the analog pins A0, A1, A2 and A3. These can also be named 14, 15, 16 and 17. That's all for building the project on the breadboard. Now is the time to start programming. Ask your students to connect the microcontroller to their computers and let them open the Arduino Integrated Development Environment, or IDE. And at the top, we name our new project, Project 15, Beating Heart. This is also the place to put our variables and declarations. We have seen that the individual LEDs are controlled by setting the rows and columns high or low. So let's first declare two arrays for the digital pins. One for the rows, which we call R, and will include the pins 2 to 9. And one array called C for the columns 10 to 17, because we have seen that the analog pins A0 to A3 can also be addressed as 14 to 17. Next, we will create a binary matrix reflecting the 8x8 structure of the display. In this matrix, we design first a big heart by giving the LEDs that should be on a 1 and the ones that are off a 0. We do the same for designing a small heart image. In the void setup, we initiate the Arduino pins as outputs. We do that by running a small program that iterates over the pins we defined in our arrays R and C, avoiding the manual task to set each individual pin to output. Next, we go to the loop function of our program. Remember that we have to apply the principle of multiplexing to display a small heart and a big heart. By alternating these two images at different times, we create the illusion of a beating heart. So in our void loop, we have two for loops, one that defines an integer j as 0, and as long as j is smaller than 100, j is equal to j plus 1. And at that time, it will display the big heart. The same for the small heart. That's it for our void loop function. As you have seen, we have called a new function display. This is not a standard Arduino function, but a function that we need to create ourselves. Functions are a handy way to make your programming easier to understand and to copy parts for future projects. Functions must be created outside of the void setup and void loop curly brackets. In this case, we create a function void display that works with an array we call data and consists of two matrices, each with 8 elements, so 64 in total. The first thing we do is to set all the columns to low. Therefore, we create a for loop with a local variable c to iterate between 0 and 7 in order to set all 8 columns to low. And here we use the array c that we defined previously. So digital write of the array c, and we set it to low. Within this for loop, we create another for loop to control the rows. Similarly as with the columns, we introduce a local variable r that will iterate around the rows and write the data defined by the variables r and c. So for the integer r equal to 0, and as long as r is smaller than 8, r is set to r plus 1. And what do? We do a digital write of the array r with the data in our r and c variables. Then we close with a delay and we add the smallest delay possible. Later you can ask your students to change the values and see what is happening on the display. And we finalize with a new function called clear to remove any empty display light that is left. Let your class do the mental exercise with a number of R and C combinations, just to make sure that they grasp the logic of these two for loops. Within the previous function, we introduced the function clear, which we now also have to create. This function will set all the rows to low and all the columns to high, thus clearing the display completely and making it ready for the next iteration. This can be done with a simple for function and two digital writes. A digital write on R and a digital write on the array C. Let your students run the code. They will see the moving image of a beating heart. If not, tell them not to panic but to do the step-by-step verification of both the breadboard and the programming. Before we close this lesson, we just need to explain the difference between global variables and local variables. In the previous lessons, we always stressed the need to declare variables at the top of the program. That is correct for variables that are needed throughout the program. With the creation of functions, however, we make use of variables that only change in value between the brackets of that specific function. To avoid that a global variable would interfere with a variable that may have another use in a function, we create local variables. And these variables may have the same name, like j, but will mean different things in different functions. This concludes our project number 15, the beating heart. What did we learn? Well, first of all, we learned about the working of an 8x8 LED matrix display. We learned about the use and the usefulness of functions in your program. Your students now understand the difference between global and local variables. But the most important, teamwork makes the dream work. There are many assignments that you can give your class. Here are just a couple of examples. Describe the working of a human heart and the blood vessel system, also known as the cardiovascular system. How many times does a heart beat per minute at rest? And calculate that into how many beats in a day, a week, a month, a year, maybe even 25 years. And can you find some creatures who don't have a heart? And what's their alternative? These are just some suggestions. Use your own imagination and experience to assign fun tasks to your class. I hope that you and your students enjoyed this project and that you are eager to start with project number 16. In that lesson, we will work with an LCD liquid crystal display, creating a very expressive frog. Bye-bye for now, and looking forward to meet all of you in the next lesson.